The moment your temperature starts climbing, most people do the same thing. They reach for ibuprofen or paracetamol and wait for the fever to drop. Get the temperature down. Fix the problem. But that instinct gets the biology exactly backwards. When your body runs a fever, it hasn't lost control. It's operating precisely as designed. We treat fever the way we treat a car engine that's overheating. Something's running too hot. It needs to be cooled down. The heat itself is the problem. Your body has a thermostat. It sits in the brain and normally keeps your core at 37 degrees Celsius. A fever isn't that thermostat breaking. A fever is that thermostat being deliberately reset to a higher target. Your body is essentially told, hold 39 degrees, maybe 40. And then it works efficiently to reach that new target. The dangerous version, heat stroke, is something completely different. In heat stroke, the thermostat is overwhelmed. The temperature rises and can't stop. That version is genuinely dangerous. In a fever, the opposite is true. The thermostat is working perfectly, just at a higher setting. Fever doesn't begin with heat. It begins with detection. When a pathogen enters your body, a bacterium, a virus, immune cells are already waiting. These cells carry molecular sensors on their surface. The sensors are designed to recognize markers that pathogens carry. Markers that your own cells don't have. The moment a sensor locks onto one of those markers, an alarm fires inside the cell. The immune cell shifts into war footing. With the alarm triggered, the immune cell releases signaling proteins into the bloodstream. These are the body's fever messengers. Their destination, the brain. But the brain is protected by a tight seal. Most substances in the blood can't get through it. So how does the message get there? There are small regions on the brain's surface where this seal is thinner. The messenger proteins act on those regions. This triggers production of a second molecule, the one that actually resets the thermostat. That reset signal reaches the brain's temperature control center, and the target temperature shifts upward. This is also what ibuprofen and aspirin block. They stop the enzyme that produces the reset signal. No reset signal, the thermostat returns to 37. The fever breaks. In an untreated fever, the thermostat is set to 39 degrees. Your actual temperature is 37. From the thermostat's point of view, you are 2 degrees below target. The body reads this exactly the same way it reads, stepping into a freezing room. You are cold. Generate heat. So it shivers. Muscles contract in rapid cycles, and that work produces heat as a side effect. A person shivering hard can increase their heat output by up to 5 times. The blood vessels in the skin narrow, trapping heat inside the body's core. The skin goes pale, you pull on blankets, you curl up small. Every sensation says you're freezing. Your core temperature is rising the whole time. Now the temperature's elevated. Here's what that actually accomplishes. Many bacteria and viruses grow best at exactly 37 degrees Celsius. That's the temperature they spent millions of years adapting to exploit. Raise it even 2 degrees, and their growth rate drops significantly. The common cold virus thrives at around 33 degrees, the temperature inside your nasal passages. Above 37, it replicates poorly. That's partly why cold viruses stay in your nose and throat. Your warmer lungs are inhospitable to them. But the heat does more than slow the enemy. The immune cells that hunt and destroy infected cells become far more effective at fever temperatures. The immune system's targeted fighters circulate more efficiently and multiply faster. The first responders, the cells that track and consume pathogens, grow more aggressive. The fever's doing both, slowing the pathogen and amplifying your defenses. The exhaustion of a fever isn't a side effect. It's a tactic. Running a fever costs roughly 10 to 13% more energy for every degree of temperature rise. Every calorie you spend moving is a calorie not spent fighting. The fatigue is the immune system enforcing its energy budget. Losing your appetite during a fever is also by design. Most bacteria need iron to reproduce. When the infection begins, the body quietly locks its iron away inside storage proteins. Out of reach. Less food means less new iron coming in. The body is starving the bacteria of a resource they need to multiply. The muscle aching works as a second brake. It makes staying still feel like the only sensible option. And when the infection is cleared, the signaling proteins drop. The reset signal disappears. The thermostat returns to 37. The body's now genuinely hotter than its new target. So it does the opposite of what it did at the start. Blood vessels widen. Sweating begins. Heat escapes. The fever breaks in a wash of sweat. That's not a crisis. That's the all clear. When researchers studied what happens when you suppress fever during flu season, they found something unsettling. Fever-reducing medicine returns body temperature to the range where the virus grows best. The infected person feels better faster because the sickness signaling is suppressed. But the virus replicates more freely. They may stay contagious for longer. The person feels better. The infection does not. The evolutionary evidence is harder to argue with. Lizards infected with bacteria will seek warmer environments, deliberately moving to bask in more heat. They can't generate heat internally the way you can, so they use the sun. When researchers prevented infected lizards from doing this, their death rate was dramatically higher. Fever has been found in fish, in insects, in reptiles. This mechanism has been conserved across more than 600 million years of animal evolution. Evolution doesn't keep energy-expensive responses unless the benefit outweighs the cost. That fever, when you feel it, that's not your body in trouble. That's your body making a deliberate choice, using tools older than any medicine ever invented. The miserable part, the shivering, the aching, the sweating, that's the price of the fight. And most of the time, it's a fight your body is winning. See you in the next one.